Welcome to linked lists. This will be our first data structure. And to explain it, I'm going to start by bringing up a list. This is just the normal list that is built into Python. And then I'll go through and change this step by step to turn this into a linked list to highlight the differences between the two. So the first difference is that a linked list does not have indexes. So I'll remove the indexes here. The next thing is that a list is in a contiguous place in memory. These are all right next to each other in memory. With a linked list, all of the nodes are going to be spread all over the place. Now, another thing that I like to do when I move to a different data structure is I like to change the color and the shape so we can keep these separated in our mind. So I'm going to change this from these being green squares, and I'm going to change them to purple circles. So also with a linked list, we have a variable called head, and it points to the first node in the list. And then we're also going to have tail point to the last item, and then each node points to the next, to the next, to the next. And the last one is just going to point to none. So to emphasize that these are going to be spread out in different places in memory, I'm going to bring up a memory space, and the linked list is going to look more like this. But because one points to the next, to the next, to the next, you're able to find all of your nodes without losing any data. That is as opposed to a list, which is going to look something like this. And because these are all in a contiguous place in memory, this is why we can have indexes and access those indexes O of 1, because we can map each one of these indexes to a specific address in memory. All right, that is our quick overview of linked lists and how they compare to lists. So in this video, we're going to talk about linked lists, big O, and I'm going to walk through every method that we're going to create for a linked list and what the big O for that method is going to be. So I'm going to start by bringing up a linked list. We have our head and our tail. And our first method is going to be to append a new node to the end of the list. So in order to do this, we have to have the last node point to it. Tail is going to point to it. And now we add it into the list. This is O of 1. The reason being, it doesn't matter how many nodes we have in the list. The number of operations to add it to the end is exactly the same. But what about when we remove the item like this? It would seem that all we have to do is have tail point to this node and we're done. But when we are removing from the end of a linked list, it's more complicated than that. In order to have tail point to that last node, we have to have that pointer there be set equal to something else that is pointing at that node. Remember, these are all just pointers, so we have to set it equal to another pointer. And the only thing that points to the 7 node is this pointer. So in order to get to that node, we have to start at the head, iterate through the list until we get to that pointer. Then we can set tail equal to that pointer, and that points it at the 7 node. But because we had to iterate through the entire list, this is O of n. Now let's look at adding and removing items from the other end of the list. So we're going to add an item to the front. We need to have that 4 point to the 11 node. The head points to the 11, so we'll have the next pointer from 4 be set equal to head, and that points it at that node. And then we have head point at the new node, and that adds it into the list. It doesn't matter how many items we have in the list. It's going to be the same number of operations to add an item on the front of the list, so that is O of 1. Now let's look at removing that 4 node. The first thing we need to do is have head point at that 11 node. We can do that by saying head is equal to head.next, and that moves that over. And then we remove that item from the linked list. Once again, this is going to be O of 1, because it doesn't matter how many items we have in the list. It's the same number of operations to remove that. Now let's look at adding an item somewhere in the middle of the list. Let's say we're going to insert that 4 after the 23 node. In order to find that node, we have to start at the head and iterate through the list until we get to that 23 node. Now we want the 4 to point at that 7 node. And this pointer here is pointing at the 7. So we'll set the pointer from the 4 equal to that. That points it there. We have that 23 node point to the new node, and that adds that into the linked list. But because we had to iterate through the list, this is O of n. Now let's look at removing that 4. The same thing happens here. We start at the head and we iterate through the list until we get to the 4 like this. Let's move this down here. We want the 23 to point at that 7 node. So we're going to set the pointer from the 23 equal to the pointer that's going from the 4 to the 7, like that. Then we can remove the 4 from the linked list. Once again, we had to iterate through the list. This is O of n. So now let's look at lookup with a linked list. Let's say we're going to look for that number 23. We have to start at the head and say, is this 23? It is not, and keep going through until we find it. Also, with a linked list, if we're going to look at this by index, and the 23 is at the index of 2, you have to start at the head and iterate through the indexes until you get to the index of 2. This is something that is different than lists, because lists, you can do this by index as O of 1. But with a linked list, both looking it up by the value or looking it up by index is O of n. Okay, so let's move these out of the way. I'm going to bring in a table here that compares linked lists with lists. Now, all the gray ones is the same either way, but there are a couple that are better for lists, popping an item off the end and looking up by index. But with linked lists, if we add or remove from the beginning of the list, it's O of 1 versus O of n with a list. So I will attach this chart as a PDF to the resources for this video, but that is the overview of linked lists, big O. This under the hood. So we're going to start with our diagram like this. And when we append an item, when we say this is equal to this and tail points to this, and we add this into the, okay, so now we're going to look at linked lists under the hood. So we're going to start with our diagram like this. And when we append an item, when we say this is equal to this and tail points to this, and we add this into the list, what is really going on to make that happen? So to understand that, you have to understand first what the node is. So first of all, the node is all of this. It is not only the value, it is also the pointer. Both of these together make up the node. So still, what is it? It's essentially a dictionary. where value is 4 and next is equal to none. So this isn't exactly how this works. You can't use the same syntax to access it, but you'll see it's very similar as we get to the end of this video. But you can think of it like this. So when you add this to the linked list, the 7 node also is a dictionary. But how do we have the 7 node point to the 4 node? We do it by just having the next value of that 7 node be the 4 node. And the same is true of the 23 node, and the 3 node, and the 11 node. And then we have head pointing to it, and then we have tail point to the last item. So this is basically what's happening when you see this. So let's flip it back to this and look at this in VS Code. So up here, we have a variable named head, and we just set it equal to this set of nested dictionaries. So I have a line down here of code that is going to print out the number 23 right here. So if you look at how we're going to have to traverse this, we're going to have to start at head, and then we're going to say next, and then next again, and then value. And that's what we're going to do down here with this print statement. Head, next, next, value. So I'm just going to run this, and we get our number 23 here. Now, if this was a linked list, and this code is not going to work right now, I'm going to come down here to the bottom, and I'm going to uncomment this. If this is a linked list, we would say print my linked list dot head dot next dot next dot value, and you would print out the number 23. So the syntax is a little bit different than if you're going to use dictionaries. But this idea that you're going to have these be in different places in memory, one points to the next, the syntax is very similar. You can think about it as a set of nested dictionaries. And that is linked lists under the hood. So now let's create our constructor for our linked list. And we're going to start it out like this. With classes, we're going to capitalize the name of the class. So that names the class, and then we'll build out the constructor like this. And we saw this in the class video that we start with a double underscore, then a init to initialize this, and another double underscore, and that there's always going to be self as one of the parameters, and this is how you tell that this is a method inside of a class instead of a function. And then we're also, in this case, going to have value as a parameter, and we're going to use that to create the first node at the time that we initialize the linked list. But before we get into building out this constructor, I'm going to bring in just the first line of 3 other methods that the constructor has a couple of things in common with, and you'll see why I'm doing this in a second. They are append, prepend, and insert. So the first thing these all have in common is that we pass a value to all of these. And to show you the other thing these all have in common, let's look at what each one of these does. So the constructor, it is going to create a node. It's also going to initialize the new linked list, but it's going to create a node. The append method is going to create a node and then add that node to the end. Prepend is going to create a node and add that node to the beginning. Insert is going to create a node and then insert that node at whatever index where you want that. So you can see these all create a new node. So we don't want to write the code for creating a new node 4 different times. So what we're going to do is we're going to create a class that does nothing but create nodes. And we're going to call that class node. So when any one of these 4 methods needs to create a node, it will call on the node class to create it. And the only thing this is going to contain is a constructor that we're going to pass a value so we can assign it to the node. As for the rest of the constructor, let's look again at what a node is. It is really this. So the node is going to contain value and next. And when you have variables that apply to a specific instance, remember we use the self keyword, self.value and self.next. So the constructor for the node is going to look like this. So when we call on the node class, we're going to pass it a value. That is what this is here. And then it gets passed to the specific instance of node. Now that we have a way of creating nodes, we can build out our linked list constructor. So let's bring this back, and our constructor is going to start off like this. So we're going to pass it a value so we can create the first node in the linked list at the time that we create the linked list. So we're going to have a variable new node, and that's going to be equal to node with a capital N. That means it's going to call the node class, and we're going to pass this value here to the node class, and that creates the node. Then we say self.head equals new node. So we'll bring the head in here, and that points to the new node. Also, self.tail equals new node. Now we have tail also pointing to the new node. And then we're going to keep track of the length. So we're going to start the length out by being equal to 1. And that is our linked list constructor. Now that we have this, we can create a new linked list. And we can do it like this. My linked list equals linked list. Notice this has the capital L. It is calling the linked list class, and we are passing it the number 4. And by writing this line here, the my linked list, you are creating all of this. You have created a head and a tail. It points to the new node. It assigns the value of 4 to that new node and gives the linked list a length of 1. So now let's create our constructor for our linked list. And we're going to start it out like this. With classes, we're going to capitalize the name of the class. So that names the class, and then we'll build out the constructor like this. And we saw this in the class. So now let's create our constructor for our linked list. And we're going to start it out like this. With classes, we're going to capitalize the name of the class. So that names the class, and then we'll build out the name of the create our constructor for our linked list. And we're going to start it out like this. With classes, we're going to capitalize the name of the class. So that names the class, and then we'll build out the constructor like this. And we saw this in the class video that we start with a double underscore, then a init to initialize this, and another double underscore, and that there's always going to be self as one of the parameters, and this is how you tell that this is a method inside of a class instead of a function. And then we're also, in this case, going to have value as a parameter, and we're going to use that to create the first node at the time that we initialize the linked list. But before we get into building out this constructor, I'm going to bring in just the first line of 3 other methods that the constructor has a couple of things in common with, and you'll see why I'm doing this in a second. They are append, prepend, and insert. So the first thing these all have in common is that we pass a value to all of these. And to show you the other thing these all have in common, let's look at what each one of these does. So the constructor, it is going to create a node. It's also going to initialize the new linked list, but it's going to create a node. The append method is going to create a node and then add that node to the end. Prepend is going to create a node and add that node to the beginning. Insert is going to create a node and then insert that node at whatever index where you want that. So you can see these all create a new node. So we don't want to write the code for creating a new node 4 different times. So what we're going to do is we're going to create a class that does nothing but create nodes. And we're going to call that class node. So when any one of these 4 methods needs to create a node, it will call on the node class to create it. And the only thing this is going to contain is a constructor that we're going to pass a value so we can assign it to the node. As for the rest of the constructor, let's look again at what a node is. It is really this. So the node is going to contain value and next. And when you have variables that apply to a specific instance, remember we use the self keyword, self.value and self.next. So the constructor for the node is going to look like this. So when we call on the node class, we're going to pass it a value. That is what this is here. And then it gets passed to the specific instance of node. Now that we have a way of creating nodes, we can build out our linked list constructor. So let's bring this back, and our constructor is going to start off like this. So we're going to pass it a value so we can create the first node in the linked list at the time that we create the linked list. So we're going to have a variable new node, and that's going to be equal to node with a capital N. That means it's going to call the node class, and we're going to pass this value here to the node class, and that creates the node. Then we say self.head equals new node. So we'll bring the head in here, and that points to the new node. Also self.tail equals new node. Now we have tail also pointing to the new node. And then we're going to keep track of the length. So we're going to start the length out by being equal to 1. And that is our linked list constructor. Now that we have this, we can create a new linked list. And we can do it like this. My linked list equals linked list. Notice this has the capital L. It is calling the linked list class, and we are passing it the number 4. And by writing this line here, the my linked list, you are creating all of this. You have created a head and a tail. It points to the new node. It assigns the value of 4 to that new node and gives the linked list a length of 1. So let's go over to VS Code, and we'll look at our constructors that we created, one for the node, one for the linked list, and then run this line of code here and look at what it creates. Okay, so let's work through this in reverse. We're going to print my linked list.head.value. That's going to be the value of that first item. And we create that first item in the linked list. When we create my linked list and set it equal to linked list, we pass it the number 4. And that's going to initiate this linked list constructor. The linked list constructor is going to create that first node with this line here, which calls the node class and creates the node. Once we've created the node, we have head and tail point to it here. And that's why we can come down to here where it says print my linked list.head.value and be able to get to that value. So I'm just going to run this. And that gives us that value of 4 of that first item. All right, so it looks like we have a working linked list constructor. So in order to look at all of the values in a linked list, I created a method called print list. So I'll just walk through this quickly. It's pretty simple. It's called print list. Then we have the variable temp equal to self.head like this. And then we just have a while loop that goes through the list. And while temp is not none, in other words, we haven't reached the end of the list, we're going to print temp.value. In this case, that's 11. And then we say temp equals temp.next. And that just moves that over, and we'll print the 3 and the 23 and the 7. Then we reach the end where temp is equal to none, and then we stop running the loop. So this is pretty simple. We'll be using this as we go through the linked list methods that we're going to create. I just want to point out that this is not a built-in method. I'm creating this. And I've also created similar methods to print out the contents of all of the other data structures that we're going to create in the course. I won't walk through that when we get to the other data structures, but understand when we do print graph, that is something that has been created. All right, that is print list. So now we're going to write the method to append an item to the end of the linked list. So that's going to look like this. We're going to create a new node. We'll have that last item that was in the list point to the new node. We'll have tail point to the new node, and that adds it into the list. So there were 2 things we did here, last item and tail pointing to the new node. But we do have an edge case for when we don't have any items in the linked list. Obviously, we can't have the last item and tail point to the new node because there is no last item. In this situation, we're going to have head and tail point to the new node. So if you want to code this, these are the steps for doing the append method. Pause the video here, go over to VS Code and see how far you can get with this, or you can write the entire method and then come back and we'll walk through it. So now we're going to get into the code. So of course, with the append, we're going to pass it a value in order to create that new node. And it has that self keyword in the parameters. That's how you know it's a method inside of a class versus it being a standalone function. So we'll say new node equals node. We'll pass it the value that we pass the append method, and then the node class will create our node. I always like to code for the situation where these data structures are empty like this first, where head and tail is going to point to the new node in this case. So in order to do this, we have to determine, is the list empty? So I'm going to say if head is none, which is the case here, we'll set head equal to new node like this, and then we'll set tail also equal to the new node, and now head and tail point to the new node. So let's take this code and add it in with the rest of our code like this. This is what we have so far. So now let's code for the situation where there are items already existing in the linked list. We'll say else, and now let's build out this else statement. So we're going to say tail.next equals new node, okay? And that is tail.next. We're setting it equal to the new node like that. And then we're going to move tail over by saying tail equals new node. That moves that over and adds that node into the list. Now let's add this else code back in with the rest of our code like this. Okay, so let's look at what we've done here. We've created a node. We've tested to see, is this list empty? In this case, we're going to do this. Otherwise, we're going to do these steps here. The only thing left to do is to increase the length of the linked list by 1. And there's one other thing I'm going to do here, and this is completely optional. I'm going to have it return true. And as a standalone method, this is actually not necessary for the append method. But the reason I have it in here is in a few videos, we're going to write another method that calls on the append method. And that method requires a true or false to be returned. So we're going to look at this code in a moment in VS Code. And when we do, we're going to create a linked list that looks like this. We're just going to initialize it with a node with a value of 1. And then we're going to see if our append code works by appending another node with a value of 2. And then we'll print out the linked list with our print list method that we created in the last video to see if we have a 1 and a 2 in our linked list. All right, so let's flip over to VS Code. So I just want to point out that our append method down here, which we will look at in a moment, is a method inside of the linked list class. Sometimes if you're new at this, it's hard to visualize where the new code that we've written fits in with the rest of the code. So I just want to show all of this. We have our constructor for the linked list here, our print list, and then we'll scroll a little bit here, and that is our append method. Now down here, what we're going to do is we're going to create a new linked list with the value of 1, just like we showed in the diagram. And then we're going to say my linked list dot append the number 2. And then down here, we'll say my linked list dot print list. And then we should see 1 and 2 printed out. Okay, so let's run this. And there we have 1 and 2 printed out. So it looks like we have a working method for append. So now that we're getting into creating our first data structure, I just want to give you a quick reminder that it is very important to write the code. In order to get as much as you possibly can out of this course, it's not enough just to watch the videos. And as I mentioned earlier, writing the code is 90% of where you apply what you're learning. To put it another way, it is the primary practice activity in the course. So I hope you're doing the challenge to write code an hour a day for 30 days. And with that, let's get back into writing methods for our linked list. So now let's look at popping an item off of the end of the linked list. And we're going to split this up into 2 videos because this is a much more complicated operation than pushing something on. And we touched on this in the linked list big O video about how pop is a more complicated method. So I'm going to bring up our linked list like this. Pop is going to look like this. We're going to remove that last item and we're going to return it. We have 2 edge cases. The first edge case is if we have an empty linked list. And then the other edge case is if we only have 1 node in the list. So if you want to have a challenge, pause the video here and try to code this without watching the rest of the video and then come back. Otherwise, I'm going to get in deeper to the logic of how we write this, but we're still not going to get into the code in this video. We won't do that until the next video. The thing that makes this more complicated is when you move tail to the left like this and remove that last node, tail is moving the opposite direction of the arrows in the linked list. The arrows are all pointing to the right and tail is moving to the left. So let's put this back and look at this from this kind of a perspective to better understand what we're going to have to do here. So what we want to do is move tail to here, set tail.next to none, and then return the node that we've popped from the end of the list. So let's put this back the way it was and look at what we need to do that. We need tail to point to this node. In order to make tail point there, we need to set it equal to something that is pointing at that node. And the only thing that is pointing at that node is the next value in this node. So that means we have to get to this node. Well, the only thing that's pointing at that node is the next value in this node, and so on until you get to the head. So that's why you have to start at the head and move node by node through this list until you get to here. And then you set the tail pointer equal to that pointer, and that's how you get tail to point at that node. And then you say tail.next equals none. Then you return the node that you popped from the end of the list. Okay, so let's put this all back like this. So if you weren't able to code it before, if it was too complicated, this is another place that you might want to pause the video and take a crack at it, because I'm going to get into a little bit more detail of how to approach this. So I'm going to bring in 2 variables, pre and temp, and I'm going to set them equal to head. And for now, I'm going to just remove head and tail, and I'm going to move pre underneath like this. So what we're going to do is we're going to say if temp.next is not none. In other words, we're not to the end of the list. What we're going to do is we're going to set pre equal to temp, which it is already in the first iteration, and then we're going to set temp equal to temp.next. And then we're going to do it again, is that none. We're going to move pre up and temp over. And we just keep doing this, and this will be the last time that it's not none. We're going to move pre up, temp over, and now temp.next is equal to none, and these stop right here. So we're going to need that temp variable to return that node that we're popping off the end. But for right now, I'm going to remove temp, and we'll work with the pre variable first. The only thing the pre variable is for is we're going to set tail equal to pre. And that's the only thing we're going to use it for. That's going to move tail back. Then we'll say tail.next is none. That breaks this off the end of the list. And remember, temp is still pointing here. We need that to be able to return that. So we'll say return temp, and that returns this node. So we will code this in the next video. But for now, that is our intro for pop. Now let's code the pop method. So we'll start by just saying pop. We don't pass this any arguments. And remember, we had 3 different scenarios to code for. I tend to start with the one where we don't have any items. And there are a few ways to test for this. You can say, if head is none, tail is none. I'm going to, in this one, say, if the length is 0, then we'll return none. So the next situation we're going to code for is if we have 2 or more items in the linked list. And as we discussed in the last video, we're going to have 2 variables that are going to be temp and pre. Let's create those. We'll say temp equals self.head and pre equals self.head. And then we'll walk through this with a while loop. And we're saying while temp.next In other words, while temp.next is true, if it's pointing to a node, it's true. And where this is going to become not true is at the end of the list where that pointer is going to be none. So there are a couple of different ways you could write this. You could just say while temp.next, like I did here, or you can say while temp.next is not none. So this is a little bit more concise. You might argue that the other way is more descriptive and more readable. I will do it both ways in this course, but for this one, I'll just say while temp.next. And then inside the while loop, we'll say pre equals temp. And in the first iteration, pre is already equal to temp. And to move that temp pointer over, we're going to say temp equals temp.next. Okay, so let's walk through this step by step. We'll say while temp.next, and in this case, temp.next is pointing at a node, which is going to make this true. We'll say pre equals temp. In the first iteration, it is already pointing to the same node as temp. Then we'll say temp equals temp.next, which moves temp over like that. So let's walk through this all the way to the end. We'll say while temp.next, we move pre up and temp over. This is true again. We'll move pre up, temp over. And then this will be the last time this is true. We move pre up, temp over. Now we say while temp.next, this is going to be false. So we stop running the while loop right here. So for now, I'm going to remove that temp variable. It's pointing at that last node. We will need that in a minute, so I will be bringing that back. But for now, I'm going to remove that. And then we need to have tail point to that 7 node. We do that like this. Self.tail equals pre, and that's going to point that there. So that's the only thing we're going to use pre for. So I'm going to remove that. Then we need to take that 4 and break it off from the end of the linked list. So we'll do it like this. Self.tail.next. That is tail.next equals none. Okay, so that's our code for when we have 2 or more items in the list. We had also created these 2 variables. And let's add this in with the rest of our code. This is what we have so far. And then we're going to decrement the length by 1. But it still leaves us with one other edge case. That's the situation where you have one node. So let's walk through this situation. We have head and tail pointing to it. We have temp and pre set equal to head. So that's going to look like that. All 4 of these pointers are going to be pointing at this one node. So the 2 highlighted lines of code there, temp and pre, I'm going to remove those 2 and everything above it, and we'll walk through these now. So we say while temp.next. So temp.next, in other words, while temp.next is not none, we're going to run this loop. Well, right off the bat, this equates to false, and the while loop does not run. So let's remove that. And that's all we're going to use temp for, so I'm going to drop that out. Then the next line is tail equals pre. Well, they're already pointing at the same item, so that doesn't do anything. So let's remove this line of code. Then we'll say tail.next equals none. Well, tail.next is already none. That doesn't do anything. Then the only thing left to do is to decrement the length by 1. So the length was 1, because we had the 1 node in there, and we decrement it to 0. So we ran through all of these lines of code. We decremented the length to 0, but the problem is head and tail are still pointing at that node. So we have to correct that. So let's bring the code back here, and then we'll have to add a few lines of code. We'll say if the length is 0. So we have another if the length is 0 up here, but the one down here is after we have decremented it. So we had started with 1, we decremented it by 1, and then we got to 0. So the one on top is if we started with 0, and then the other one we just added is when we started with 1 item. So what we need to do is have head and tail be set equal to none, like that, and that fixes the problem. So we'll remove this, and there's only one step left, and that is to return temp, which returns the node that we just removed. Okay, so there is all of our code for pop. So we'll look at this code in a moment in VS Code, and what we'll do is we'll start out with 2 items like this. So remember, we had 3 scenarios here that we had to write code for. One, if we had 2 or more items. So we'll run pop to see if that works. Then we're going to be left with 1 item, and we'll run it again to see if it works with 1 item, and then we'll see if it also works when we don't have any items. So let's flip over to VS Code. Okay, so there is our pop method, and this is where we create that linked list that we just saw with a 1 and a 2 node in it. And I'm just going to print the list so we can see that we have a list with 2 items in it. So we'll run this, and that is our 1 and our 2. All right, so I'm going to scroll up here, and I'm going to paste. I'm going to remove this print list here, and I'm going to paste this in. So remember, we're testing to see if this works when we have 2 items, and then 1 item, and then 0 items. So these are going to be our 3 scenarios here. We're just running pop 3 different times. Okay, so I'll run this, and then you can see over here, this has returned 2 nodes, and then it returned none. So that is exactly what we would expect it to do. But what we can do also to test our code here is we can scroll up here, and instead of having this return temp, have this return temp.value, just to test it. You want it to return the entire node, not just the value. But for testing purposes, we can just type that in, run it again, and I'll do it this way. And it returns the 2 node, then the 1 node, and then returns none, which is exactly what we're looking for. So that means we have a working method for pop. Okay, so now let's do prepend. We'll bring up our linked list here, and what we're going to do is add an item to the beginning of the linked list. So first, we want that new node to point at that 11 node, the last node in the list. So we need to set the next pointer on that node equal to something that is pointing at that node. So we'll set the next node on the new node equal to head, and that points that over there. And then we'll have head point to the new node, and that adds that into the list. And of course, this is going to be a little different if we have an empty list like this. When we add it in this situation, we're going to have head and tail point to the new node. So if you want to take a shot at coding this, then pause the video here and go over to VS Code and try to write the code. Otherwise, we're going to get into the code. So we'll begin this like this. We're going to pass it a value. And of course, the first thing we're going to do is create the node with that value. And that creates our node. So we had 2 situations we were going to code for if we had an empty list or a list with items in it. Let's start with the empty one. In this situation, we're just going to have head and tail point to the new node. So in order to do this, we have to test to see, is the list empty that we're inserting into? And we'll do that by saying, if the length is 0, then we'll set head equal to the new node, like this. And then we'll set tail equal to the new node, like this. So now let's take this code and put it in with the rest of our code. So the other scenario we can have is that we actually have items in the list. So we'll say else, and let's build out this else statement. So we want that new node to point at that 11 node, and we'll set it equal to the head. And that does this. Then we want head to point to that new node. We'll do that with this line of code. And we'll say head equals new node. We'll move that over, and that adds that into the list. So now let's look at this code again with the rest of our code so far. And the only things left to do are to increase the length by 1. And in this case, we're going to return true. And this is an optional line of code here. And as I mentioned with append, I'm going to be using append. I'll also be using prepend in another method in a few videos that requires a Boolean to be returned. So that is why I'm going to put the return true in here. So we'll look at this code in a moment in VS Code, and then we will build a linked list that looks like this, and then we will prepend the number 1 to that list. So it'll start out with a 2 and a 3, and we will prepend a 1, and then we'll print the list out, and it should print out 1, 2, 3. All right, let's flip over to VS Code. There's our prepend method there. This is going to create that initial linked list with the 2 and the 3 in it, and then here we're going to print that out, that list with the 2 and the 3. Okay, and there's our 2 and our 3, and then what I'm going to do is I'm going to come down here, and I'm going to paste in our line that prepends our number 1 there. And now when we do our print list, this should print out 1, 2, 3. So I'm going to run this, and that prints out 1, 2, 3. And that is our method for prepend. So in this video, we're going to pop the first item off of the linked list. So it's going to look like this, and we're going to move head over like this, and remove this, and of course return it. And then we have a couple of edge cases. One, if we have one item in the linked list, this is similar to when we popped an item off of the other end, that we have an edge case for when we have one item, and then we have another edge case for when we don't have any items in the linked list. So if you want to code this, go ahead and pause the video here. Otherwise, we'll get into the code. So we'll say pop first, and then this situation here where we don't have any items in the linked list, we will code for this one first. We'll say if the length is equal to 0, we're going to return none. So now let's look at when we have 2 or more items in the list and write the code for that. And we are removing that first node there. In order to return that, we have to have something pointing at it. So we'll call that temp. And we'll say temp equals self.head. Then we're going to want to move head over. So we'll set that equal to head.next. And that'll move that over. We do that with this line of code. Head equals head.next. Then we want to remove that 11 from the list like this and have that be equal to none. So we'll say temp.next equals none. And that removes that from the list. So then we'll decrement the length by 1. And this brings up our edge case for when we have one item in the list to start with. So let's just walk through this like we did on the other end of the list when we were removing an item. So we have temp is equal to self.head like this. And then we'll say head is equal to head.next. Well, head.next is none. So that just sets head equal to none, which is what we do want. And then temp.next equals none. Well, temp.next is already none, so that doesn't do anything. So we'll remove that. And then I'll remove the variable as well like that. And then we decrement the length by 1. It was 1, and now the length is 0. But tail is still pointing at that one node. So we need to have tail also point to none. So we'll say if the length is 0, we'll have tail be set equal to none, and that solves that problem. Let's look at this end with the rest of our code. Okay, so let's walk through this. This is when we have 0 items in the linked list. It's length equals 0. We have another length is equal to 0 here, but it is after we have decremented the length by 1. So that second if statement applies when you started with one item. Now the only thing left to do is return temp, which is the item that we removed from the linked list. So we'll look at this code in a moment in VS Code, and we will start with a linked list that looks like this. Remember, we have 3 scenarios that we coded for. One with 2 items in the list. We need to make sure that that works, so we'll remove that. And then we need to make sure it works when we have 1 item in the list. And then, of course, when we don't have any items in the list, we want it to return none. So let's flip over to VS Code. So there is the pop first method that we just created. And then this creates that linked list with a 2 and a 1. And then we'll print that out. Okay, so there's our linked list with a 2 and a 1. And then I'm going to come down here. I'm going to remove this print list line here. Then I'm going to paste in a few lines of code here. So this is just going to run the pop first method 3 times and print out the results. So we're going to do that with the 2 items, the 1 item, and the 0 items. And we'll run this. Okay, and you can see up here that this printed out our 2 nodes, and then finally it returned none. And just like we did with the pop method, I'm going to come up here and put temp.value here. And you don't want to keep it that way. You always want to return the entire node, but to test it, we'll just return the value to make sure we're getting the right values. And there is 2, 1, and none. That's exactly what we're looking for. So I'm going to come back up here and remove the dot value to put it back the way that it should be. And that is our method for pop first. We're going to pass it an index, and then it's going to return the node at that index. So if you want to code this, go ahead and pause it here. Otherwise, we will get into the code. So forget, because we're going to use an index, I'm going to show the indexes with our linked list. I'm going to start with something that might seem obvious. In this situation, we can get something at the index of 0, 1, 2, or 3. But it is possible that someone could pass this method an index of -1. They could pass an index of 4. So we have to test for. Okay, so now let's do get. And for get, instead of showing a diagram, I'm just going to show the first line of the method. We're going to pass an index, and then it's going to return the node at that index. So if you want to code this, go ahead and pause it here. Otherwise, we will get into the code. So for get, because we're going to use an index, I'm going to show the indexes with our linked list. I'm going to start with something that might seem obvious. In this situation, we can get something at the index of 0, 1, 2, or 3. But it is possible that someone could pass this method an index of -1. They could pass an index of 4. So we have to test for this first to make sure that we have a valid index. So we're going to say if the index is less than 0 or the index is greater than or equal to the length, then we're going to return none, because obviously we can't get a node at any of those indexes. So we have to start with this. Now let's look at getting a valid index. We're going to have a variable called temp. We're going to have that point to the head. We'll do that like this, temp equals self.head. And I'm going to remove head and tail and just leave temp there. So whatever the index is, that's going to be the number of times we have to move temp over. So then we'll create a for loop that is going to run that number of times, and that will get us to the correct node. So we'll say for underscore in range index. So if it's an index of 2, the range is going to go from 0 to 2. And we'll talk about that underscore here in a second in case you've never seen that. And then we'll say temp equals temp.next, and that will move temp along the linked list. Normally we have a variable in this spot. A lot of times we will call that I, but you're only supposed to put a variable there if it's going to be used inside of the for loop. For example, you could say print I, and that is using the I inside of the for loop. If you're not going to use the variable in the for loop, like this, we replace the I with an underscore. Okay, so now back to our for loop and moving that temp variable along. If this was a 2, we'd go 1, 2, and then temp would be pointing at the node that we want to return. And once we've done that, we can just say return temp. Now let's look at this code and with the rest of our code. Now this was all pretty straightforward here. The only real gotcha that you may not have thought about is this part here to test to see if the index is valid. All right, so we'll look at this code in a moment in VS Code. And when we do, we will create this linked list, 0 through 3. And in this situation, each value of a node is equal to the index of a node. So we're going to say get the node at the index of 2, and that should return the node with the value of 2. So let's flip over to VS Code. There is our get method there. And this is going to build our linked list with values 0 through 3. Then down here, we're going to get the node at the index of 2. And remember, that should be the one with the value of 2. So let's run this. And once again, you can see that it's just returned a node. So we'll come up here and add .value to make sure it's returning the correct node. And then we will run this again. And that returns the value of 2. All right, so I will remove the .value from our get method here. And it looks like we have a working method for get. Okay, so let's do our set method. And set is going to look like this. The first thing I want to point out about set is we can't actually call it set. I call it set value here. Set is a keyword in Python, so I can't use that as a method name. So let's bring up a linked list like this. So what we're going to do with set is we're going to have a variable that will iterate through to a particular index, and then we'll change the value. So let's say we pass this method the index of 1 and a value of 4. Then temp is going to go here, and then we change that value to 4. I'm going to go ahead and change this back to 3 for now. But now that you have an idea of what we're doing here, if you want to code this, go ahead and pause the video here. And now I'm going to get into the code. So this variable temp, we're going to declare this like this. In order to get temp to point at the appropriate node, you may have noticed is very similar to get. We're going to iterate through and get to a particular node. If the index is out here, obviously we can't set a value there. We can't set a value here. So we can use all of that code that we used in get to test to see if the index is valid or to have temp point to the appropriate node. Or we can do something like this. We'll just say temp is equal to self.get, pass the get method the index, and then have temp point to the appropriate node. And this is the first time that we've seen that we can use another method inside of a method that we're building. Now, when we set temp equal to the get method for that index, get is going to return one of two things. It is either going to return none if it's an invalid index, or it's going to return a node. So the first thing we have to do is test to see, is this pointing to a node, or is temp equal to none? So we'll say if temp, and you could write this as if temp is not none. And that might be easier to read. I went for the more concise version here. That means that it is pointing to a node and it's not pointing to none. We'll say temp.value equals value. This is the value that we passed the method. And we had previously said that this value would be 4, so we'll change that value to 4. And then we will return true. If the get method returns none, it's an invalid index, then we will return false, which is to say this if statement won't run. We will bypass that and go directly to returning false. So that is our set value method. It's very concise because most of the code for this is in the get method. Then we're just testing to see what that method returned. So we'll look at this code in a moment in VS Code, and we will build this same linked list that we've been using in this video. Then we will run the set value method with an index of 1 and a value of 4, which will change this node. Okay, so let's flip over to VS Code. So there is our set value method, and this creates that linked list with 11, 3, 23, and 7. So let's just print that list out. And we have 11, 3, 23, and 7. Okay, so what I'm going to do is in between this creation of the linked list and this print list, right in between, I'm going to paste this line here. So this is going to set the value at the index of 1 to be 4. And then after that, we will print out the list, and we should see that change in the list that is printed out. And you can see up here that the item at the index of 1 has been changed to 4. So it looks like we have a working method for set. Okay, so now we're going to insert a node into our linked list. And it's going to look like this. At a particular index, we're going to insert a new node that has a particular value. So if you want to code this, go ahead and pause this here. I haven't really given anything away by showing this line, but it is a good way to describe what it is that we're doing. Otherwise, we'll get into this. So I'm going to bring up our linked list here with the indexes. And this is going to be the item that we insert. And just like we saw with get and set, we can't insert this at an index that is out of range. So we can't have anything at the index of -1, or we could say an index less than 0. And we can't have this at an index out here, or we could say an index greater than the length. So we'll say if the index is less than 0 or the index is greater than the length, we're going to return false. So let's remove that and look at if we insert at the index of 0. If we insert this here, we've already written code for adding an item to the beginning of a linked list. So we can say if the index is 0, we're going to return self.prepend and pass it the value. So there are two things I want to point out about this line of code. First, it has the return keyword in here, which is saying once this prepend method runs, we're going to be done. We're not going to keep running code in this method. The other one is the self keyword. So we are running this on this particular instance of the linked list. So we'll remove that. And of course, we can do the same thing on the other end of the linked list. We'll say if the index is equal to the length, we're going to return self.append, very similar to what we did with prepend. So now let's look at all three of these if statements. This one here is if we have an index that is out of range and returns false. This is if we're adding this to the beginning. This is adding it to the end. So now let's look at inserting this node somewhere in the middle. We're going to insert this at the index of 2, and it will look like this when we're done. So I'm going to remove that for now. In order to do this, we're going to need to have a variable that points to the node before the index where we're inserting this. And the reason why you have it point here instead of the index where you're inserting this is you're going to need the next pointer from that 3 node to point down here. That's going to be temp.next. If you have temp over here, you don't have any way to get to that pointer, so it has to be back here. So we've created a couple of new things here. So let's write the code to create them. The first is we created this node. We'll say new node equals node, and we're going to give it the value of 4 in this case. And then we need to create that temp variable. And we can create that by saying temp equals self.get, and just pass it index -1, and it will point that to the appropriate node. Okay, so now let's look at this code. And with the rest of our code so far, we have our 3 if statements. We've created the node, and we've created the variable temp. So let's bring this back up. And the first thing we're going to do is point that next pointer on that new node up to the 23. So we'll say new node.next, and we're going to set that equal to something that is pointing to the 23 node. And that would be temp.next. So we set those equal. That will point that up there. We'll do that with this line of code. New node.next equals temp.next. And then we need to take the arrow from the 3 node that is pointing to the 23 node and have it point to the 4 node. So we'll say temp.next is equal to new node. Like this. Temp.next equals new node. That adds that into the list. So let's look at this in with the rest of our code. And the only things left to do is to increment the length by 1, and then we'll return true. Now, one of the things I want to point out here is if this is successful, here we're returning true. And if it's not successful up here, we're returning false. If you'll recall, when we created the prepend method and the append method, we had them return true, and I said that we're going to use both of those in another method later. The insert method, the way we've written this here, it has to return true or false. And by writing the prepend method and the append method the way we did, that allows us to use those inside of this method. Okay, so we'll look at this code in a moment in VS Code. And when we do, we're going to create a linked list with a value of 0 and 2. And then we're going to run the insert method and say at the index of 1, insert a node with the value of 1. Then we should have a linked list with the values of 0, 1, and 2. Okay, so let's flip over to VS Code. So there is our insert method that we just created. And this is where we create our linked list with the values of 0 and 2. And then we're going to print this out to make sure that is correct. Okay, so that is returning 0 and 2. So that is correct. I'm going to take this code. I'm just going to scroll it up here so we can zoom in. And then what I'm going to do is between this creation of the linked list and the print list right here is I'm going to paste in our insert method. And we are inserting an item at the index of 1 with the value of 1. So with that new node inserted, when we do our print list here, this should print out 0, 1, 2. So let's run this. And that is returning 0, 1, 2. So it looks like we have a working method for insert. Now let's remove an item from our linked list. We'll remove an item at a particular index. So if you're going to code this, go ahead and pause it here. Otherwise, I will move forward with this. So I'm going to bring up a linked list here with our indexes. And just like we've seen before, we have to make sure that we don't have something out of range, like an index of -1, or you could say an index less than 0. And we can't have an index that is greater than or equal to the length. So we'll say if index is less than 0, or the index is greater than or equal to the length, we're going to return none. So if you'll recall, in our insert method, when we did our if statement for items that are out of range, we return false. But here we are returning none. So I wanted to talk a little bit about that. The reason why we return false there and return none here is because if we're successful in the insert method, we returned true. So if we weren't going to be successful, we return false. In the remove method, if we're successful, we're going to return a node. So in the if statement here, for when we're not successful, we want to return none because none would be the opposite of returning a node. So I'm going to remove this. And we have a couple scenarios that we've seen before. One would be removing an item from the beginning. So we could say if the index is 0, we're going to return self.pop first. And then if we're going to remove the last item, we would say if the index is equal to the length -1, we'll return self.pop. So we've accounted for situations when the index is out of range or if it's the first item or the last item. So let's look at removing an item that's somewhere in the middle. We'll do the index of 2. So we'll need a variable to be able to return that node. So at the end of this, we're going to return temp, but we'll need another variable to point to the item before it. And to show why we need that variable pointing at the node before the one we're going to remove, I'm going to go ahead and remove this. We need that there to be able to say previous.next points to that next node. So you have to have something to the left of that arrow. So I'm going to bring our node back. So let's create both of these variables. So we'll start with previous, and we'll say that previous equals self.get, and we'll pass it index -1. So for the temp variable, we could do something similar. We could say that it's equal to self.get and then pass it index. But the problem with that is that the get method is O of n, and there's an O of 1 way of assigning the temp variable. And we do it like this. Temp equals previous.next. We have a variable at the node before this. So this is the more efficient and therefore correct way of doing that. The other one will work, but this is more efficient. So let's look at these two lines of code with our 3 if statements. And that's what we have so far. And let's bring back our linked list. So I'm going to pop this 23 node up like this. And the first thing we're going to do is have the arrow that's going from the 3 to the 23. We're going to move that down to point at the 7 node. And to do that, we're going to say previous.next is equal to temp.next. We do that with this line of code here, previous.next equals temp.next, and that moves that arrow down there. Then we want to break that 23 node off of the list. So we'll say temp.next equals none. We'll do that like this, temp.next equals none, and that removes that item from the list. So our list had 4 items in it. Now it's down to 3 items, so we're going to decrement the length. And then the only thing left to do is return temp, and that returns that item. So let's look at this with the rest of our code. That is the entire method for remove. We'll look at this code in a moment in VS Code, and we will create this linked list that we've been working with, and we're going to remove that item at the index of 2. So our linked list, when we're done, is going to look like this. Okay, so let's flip over to VS Code. So there's our remove method, and this is where we create our linked list with 11, 3, 23, and 7. And this will print our list out. So let's just run this, and that prints out 11, 3, 23, and 7. So what I'm going to do is I'm going to scroll this up here, and in between the creation of our linked list here and our print list, I'm going to paste this line of code. So this is my linked list.remove, the item at the index of 2, and then I have a line break on the end there. So this will print out that node, and then down here, we're going to print out the linked list with that node removed. So I'll run this, and there's the node, and here's our linked list with 11, 3, and 7 with the 23 removed. I'm going to come up here and say temp.value and run this, and you can see that the node that it's removing is the 23 node, and then of course it's going to once again print out the 11, 3, and the 7. And remember, we're only doing that .value to test the code. We don't want to leave it that way. We want it to return the entire node, so I'm going to remove this and leave that as return temp. All right, so it looks like we have a working method for remove. Okay, so now we're going to reverse a linked list. This is a very common interview question. If you're going into an interview, make sure that you know this. So we'll just call the method reverse, and let's bring up our linked list. So at a high level, what we're going to do is this. We're going to take head and tail, and we're going to switch them, and then we're going to take all of these arrows one by one all the way down and have them point the other way. And that is a reverse linked list. Easier said than done. So let's put everything back the way it was and walk through how to do this. So first thing, let's switch head and tail. We'll set temp equal to head. Then we can set head equal to tail. Then we can set tail equal to temp. And now we have reversed head and tail. So let's look at the 3 lines of code to do this. We have to create the temp variable, have it point to the head, and then we say head is going to be equal to the tail, and then tail is going to be equal to temp. Simple enough. And this is our code so far. Let's bring our linked list back up here. I took head and tail out because we won't need those for the rest of the video, but we will need a couple more variables. We're going to need a variable that is on the right side of temp. I'm going to call this one after, and we're going to have one on the left of temp. I'm going to call this one before, and that one's going to point to none to begin with. And then these 3 variables are going to iterate through the linked list as we are reversing everything. So let's put this back and create these 2 variables. So after equals temp.next, and before equals none. Let's look at these 2 lines of code in with the rest. So what we've done here is we created a temp variable, an after variable, a before variable. We've switched head and tail, and now comes the hard part. We'll bring our list back up here, and we're going to have a for loop that goes through the length of the linked list. So we'll say for underscore, because we're not going to use that variable in the for loop. We've talked about that before. In range, self.length. So we're going to go the length of this. You could use a while loop instead of a for loop if you wanted to, but I'll use a for loop here. And we're going to have 4 steps in our for loop. First, after equals temp.next. And the first iteration, it already is. Temp.next equals before. So that is temp.next. This is that arrow. This is what flips that arrow over the other way. Equals before. Remember, before points to none to begin with. And the thing that makes reversing the linked list difficult is you can see there's now a gap between 11 and the 3. So you have to make sure that your linked list never breaks in such a way that you can't get to something across that gap. That is what the after variable is there for. Then we say before equals temp. We're going to move that up. And then temp equals after. And that's what gets temp across this gap. So we'll walk through this a couple of times as we go to the end and look at the logic here. After equals temp.next. This has to come first. All 4 of these have to be in exactly the right order. That has to go across before this next line that is going to take that arrow from the 3 to the 23 and flip it the other way. Now you have a gap here. So after has to be moved over before you create that gap. And you have to move before up to temp before you move temp across this gap. So those 4 steps have to be in order. So now let's do it again. After goes across, we flip that arrow over, and we can't move temp up yet. We have to move before up first, then we can move temp over. So now this is going to be the last iteration. After equals temp.next. So now temp.next is none. So this is going to make after equal to none. And then temp.next equals before. That flips that last arrow over. And really we are done here, but of course the for loop has to finish. Before equals temp, temp equals after. This is how it all concludes. And then we stop running the for loop, and we have a reversed linked list. Now let's add the for loop in with the rest of our code. And that is the method for reverse. So we'll look at this in a moment in VS Code, and we will create a linked list that looks like this, 1, 2, 3, 4, and then we'll run reverse, and it'll be 4, 3, 2, 1. So let's flip over to VS Code. So there is our reverse method, and this creates our linked list 1, 2, 3, 4, and this will print out that list 1 through 4. So I'll run this, and that prints out our linked list 1, 2, 3, 4. So come down here, and in between creating the linked list and this print list method, I'm going to paste this line of code here, my linked list dot reverse. Then we will print it, and it should print out 4, 3, 2, 1. And I'll run this, and that prints 4, 3, 2, 1. All right, looks like we have a working method for reverse.